To fulfill the various requirements of these services, the Firebee has the flexibility of being launched either from an aircraft or from the ground with rocket assistance. It may further be controlled by command radio from airborne or ground control stations. Throughout the years, the Firebee has been recovered by using a two-stage parachute system consisting of an initial drag parachute with a final main. The parachute system itself has proven quite reliable. However, drone recovery operations are normally not permitted in the vicinity of populated areas or building complexes. As a result, many times the Firebee must be recovered in wooded areas, marshlands, or the open sea. The results of impacting in these undeveloped areas, when combined with high surface winds, have on occasion made the recovery operation difficult and expensive in both manpower and materials for repair of the impact damage. It was because of these problems that the Midair Retrieval system, nicknamed Mars, was developed. The first conceptual development was performed by the U.S. Army, utilizing a CH-37 Sikorsky helicopter equipped with the All-American Engineering Retrieval system. In the USAF Ryan development program, this system was modified so that the Firebee could be retrieved in midair and towed to the desired service area. The modification included two flying poles beneath the helicopter, rigged with two two-prong hooks on the poles, and two four-prong flying hooks between the poles. This original pole rigging was changed in the Air Force program to one flying hook and two pole hooks. In addition, the poles were shortened to reduce the possibility of de-rigging and to ensure more positive engagement. An hydraulically operated winch assembly was pallet mounted on the floor to accommodate the cable, inertial reel assembly, motor, and associated controls. Upon engagement of the parachute, an hydraulically operated braking system is used to retard the payout of line and effectively absorb the engagement shock over a longer period of time. Should an emergency arise after engagement, the system is equipped with a cable cutter to jettison the drone. The main parachute may be any one of the standard sizes used on drones. The Midair Retrieval system adds an engagement parachute designed by Recovery Systems Research Incorporated. It has reinforced taped ribs from skirt to apex to ensure positive engagement and minimize hook tear-out. The engagement parachute is packed in its individual container and performs the additional function of deploying the main canopy. A 10,000-pound load line is attached at the upper end to the engagement parachute and at the lower end to the drone. The load line is attached to the apex of the main canopy during the initial phase of deployment by a 6,000-pound cord. This cord is cut 20 seconds after main chute deployment by a pyrotechnic cutter. Once the heavy attachment line is cut, the load line is held at the apex by a lighter 550-pound cord, which is broken by the shock of engagement. 6 feet up from the main canopy skirt on the load line, there is a 9-foot load line positioning flag, which is used as a reference by the helicopter pilots to align their approach. As in most flight test programs, problems were encountered. Premature detachment of the load line at the 550-pound apex tie resulted in the engagement parachute flying off to one side. In this position, it is quite difficult for the pilot to make engagement. The Army crew that made this recovery demonstrated outstanding airmanship and proved that recoveries, even under these difficult circumstances, could be made successfully. A second problem revealed in flight tests was the premature firing by static electricity of the explosive bolt in the ground release component. This was solved by grounding the bolt. On several occasions, the 10,000-pound load line separated. The cause was finally determined to be nylon-to-nylon interaction between the load line and the main canopy, which caused the load line to burn while being pulled through the main canopy. As a result, the load line position flag was incorporated to permit the pilot to locate the load line and then make the pickup so that the load line is pulled away from the main canopy. After engagement has been made, the line is braked through the inertial action of the winch, and the drone is reeled into the stowed position. Approaches are made at speeds between 40 to 60 knots, with a loss of 5 to 10 knots upon engagement. The immediate separation of the main canopy is ensured by the release mechanism designed and built by Orion for this specific purpose, permitting the helicopter to regain the lost speed in minimum time. The drone settles down in tow within 1 to 2 oscillations. The initial flight test development program was completed over a period of 6 months and 98 test flights. At the conclusion of the developmental flight test, the Air Force conducted an improvement and training program utilizing the CH-3C Sikorsky helicopter. Standard procedures were formalized, and Mars reliability improved. The all-American engineering, winch, and pole assembly installed in the CH-3C is an improved version, although operational features are essentially the same. The Air Force has deployed the Midair retrieval system and is experiencing repeated successful recoveries. Late in the CH-3C program, a 48-inch stabilization parachute was attached to the drone to dampen this swing through and stabilize the tow. Since damage has been reduced to the absolute minimum, valuable drone inventories are maintained in an in-commission status. Also, since shock damage to sensitive circuits and subsystems is prevented, overall drone reliability is improved. The Midair retrieval system provides an effective solution to the recovery problem. Maintenance turnaround time has been reduced to refuel, inspect, and pre-flight. Thus, more operational sorties are provided on a timely basis. All program objectives have been met.